Okay, hi. Hi everybody. Welcome to the community call, Kong Community Call. This is December 4th, 2018, and here at Kong, we are all in ramp up for KubeCon mode. So in getting ready for that, we are gonna have Cooper Marcus talk, I put him second, but he will actually talk first. Talk a little bit about Service Mesh, which is going to come out as part of Kong 1.0's GA. Cooper's been doing a lot of education about Service Mesh for us, and he's got a couple of blog posts coming out. So we're really excited to hear from him about how Kong thinks of Service Mesh, what our Service Mesh looks like, kind of how it's put together and what it is. And then after that, we're going to have James Callahan, who actually designed Service Mesh and built it, talk to us a little bit about where it is now and show us what we've got in terms of RC3 and what's going to come out in the future. So there'll be a little demo of that. And then after the Service Mesh intro and demo, we'll talk a little bit about where you can find us at KubeCon. KubeCon is obviously coming up. It will be December 11th through 13th in Seattle. And we're going to be there. So we'd love to meet you in person. So with that said, Cooper, I'm going to stop sharing and hand it over to you.
Sounds good. And I'm just going to assume everybody can hear me. If you can't, turn on your camera and give me a thumbs down. But otherwise, no news is good news. So, hi everybody. My name's Cooper. I'm the director of ecosystem here at Kong, and I work on a variety of things, including our hub, where we share and find ways to extend and enhance Kong. But today and recently, I've been doing a lot of work on the Kong mesh, on Service Mesh, and on sort of breaking down tricky concepts into bite-sized chunks that are easier to learn and reason about. Wow, Service Mesh, when you dig into it, is a potentially complicated topic. I've found it made my head and the head of some of my colleagues sort of explode a little bit at first. And then we really dug into it and we realized, wait a sec, I think it's actually much easier than folks fear. So let's talk a little bit about what it is and how it works. But first, James, how long should I talk for?
As long as you want it.
3 minutes or like 30?
No, as long as you want it.
Okay, all right. So I'm going to show some pictures and then get into some words. So in the olden days, and of course in many monolithic applications, what we have are function calls between objects, right? There is no need for a service mesh here because all of the communication is happening within the application. And even when you start to scale your monolith and deploy multiple instances of it, we still have all of our communication happening within the application. But what happens when we start going to microservices? Now, have a look at these two diagrams. And what you'll see is that we basically just refactored the classes in the monolith out into independent services. And we've changed function calls between the objects to be network calls between services. Those little changes make a huge difference that we need to start to address. And the core reason we need to address it is because the network has latency and unreliability. Compared to objects making calls to one another within an application, which is luckily fast and reliable for the most part, the network is just a Wild West. Who knows what's going to happen, right? Latency issues, particularly as you get into modern deployment scenarios like hybrid cloud or calling external APIs that are kind of just like little services in your microservices arrangement. You can imagine all the unreliability that can happen across these network connections. So Service Mesh was developed, the idea is sort of a response to the problems we encounter when we refactor our monolith into microservices. Let's see a chat message.
Oh, no, it was me.
Okay, all right. You can let me know if someone.
I will let you know.
Okay, great, thanks. All right. So.
Which does mean that if you do have a question, do just pop up, ask us in chat, or anywhere you want.
Yeah, you're also, everybody's welcome to unmute if you would like to just interrupt us. That's also very welcome.
Cool. Is one of our speakers on?
What?
We can hear them if they talk.
Yes.
Great. All right. So, so why do our calls drop, and why is our home internet bad, and why downloads sometimes fail? It's all about the network, right? The network is the problem. It's kind of amazing, right, that we've gotten this far with computers, and we still haven't totally like solved the network. But in a way, it's not. It's meant to be a place where we can deal with problems, right? The whole core concepts of the internet routing protocol are that it's decentralized and fault tolerant. Things can go wrong and we can recover. But when we're running applications that are talking to one another, we need that recovery. We need those things going wrong to be minimized, lest we get impacted in a way that we weren't when we had such reliability in these function calls within an application. Okay, so the network's the problem, right? We've got latency and routing issues. We've got potential security issues. There's now communications happening across the proverbial wire. And we've got observability issues as well. Observability here refers to the fact that the tooling we have to understand what's going on in these communications between microservices is much less mature than the tooling we have to understand what's going on within a given application. Service mesh is also a response to this sort of less maturity on the observability side of things, seeing and understanding what's going on. So let's have a quick look at some of those issues, right? First of all, we've got latency issues. Network latency. Network's typically very fast, but in a microservices architecture, a given request from a client and response may involve many services talking to one another across the network, and all that latency adds up. Security as well. We've got the communications happening over the wire, as I mentioned. We want them to be encrypted, and furthermore, we want the services to both know that they're talking to a reliable party on the other side. When we are in our monolith, there's no concern here. I mean, we're just within an application. No function call or function call is going to have a security issue. But when we communicate across the network with a service on the other side that's being potentially built by another team, maybe even being run and managed by a whole other company, we need some assurance that we're communicating with the service we intend to be communicating with. Routing too, as well, we now have the opportunity to have new versions of our services, and we need to be able to control the routing between these services so we can try things out and roll forward or back to new and old versions. And then, of course, we need error handling and resiliency. The network itself is unreliable. The services may be unreliable. We need to be in a position to check the health of these things, stop sending traffic to an unhealthy service, start sending it when it becomes healthy again. And then, of course, observability is related to collecting the information from across this distributed service architecture and bringing it all into one place where we can see it and reason about it and share it and use it to improve our performance. So these are all problems that service meshes solve. The service mesh is really a pattern. It's not a feature and it's not a product. It's a way of doing things. And I'm going to switch to a second here to some draft documentation I've been working on, and I want to share here. So what is a service mesh? Well, I think a service mesh is a way of solving problems related to security, reliability, and observability that occur when multiple applications are communicating with one another within a given computing environment by routing the inter-application communications through local proxies without requiring changes to the applications. Now, you're going to see some of this in a blog post coming up, but I think it's helpful to sort of level set here on what it is we're talking about. Now, first of all, we're solving problems, right? Service mesh is a problem-solving approach. We caused ourselves problems by going from the monolith to microservices. We also caused ourselves a lot of benefits, right? We now can have engineering teams moving independently. We have more agility with services that can be recombined to meet new business needs and new challenges. So, microservices have lots of good aspects, but they also have problems compared to monoliths. So service mesh is a problem-solving approach. And the kind of problems we're solving are typically security, reliability, and observability problems that occur when applications are communicating across a network. Now, these problems occur when multiple applications are communicating. I point that out because these aren't the sort of security, reliability, observability problems you have within a monolith, right? We're solving problems that have to do with microservices communicating or applications in general communicating across the network. I've been saying microservices, but really, they don't have to be micro, right? You could have a mesh of monoliths here. Over here, where we say service, service, service on the right, they could be big, they could be small, they could be functions, tiny, doesn't really matter. Now, the service mesh is operating within a given computing environment. The internet is a giant computing environment, but really it's a bunch of smaller environments connected. And service mesh doesn't really apply to internet scale problems. It's going to apply much better to a computing environment that you have access to, that you can control. Deploying and running service mesh is going to typically require a level of access to the hosts that are running your applications that you don't get when they're somebody else's hosts. That is, if you want to improve the reliability of your communications with the, say, Facebook API, you do not have permission to go install service mesh proxies on Facebook servers. There's ways of addressing that, but we're typically talking about solving problems within a computing environment, one that you sort of control or can access.
Which isn't to say that service mesh doesn't actually sometimes help in those scenarios.
In the distributed scenarios, it definitely does.
No, even for talking to external services.
Sure, you could route your external service traffic through a proxy and get some benefits, right?
No, so when you were to add, say, an external service to Kong, and talk to it through a service mesh, all of the Kong's health checks, you can actually configure them to apply to an external service.
That's true.
And you can have Kong do retries to the external service. So it's not without benefits.
That's quite true. And maybe this part of the definition is also sort of so obvious that I should just take it out. I mean, of course you can't control other people's servers. Duh. So we'll see. This is work in progress. Now, the way we're solving these problems here is routing the inter-application communications. That's the communication between the applications through proxies that are local to those applications. And importantly, we're not changing the applications. There are ways of solving these distributed architecture problems that involve changing the applications. I've heard some of those sometimes called service mesh, but in my mind, they don't really meet the definition because they require a tight coupling with all the application development teams. If you're going to go talk to all of your engineers across all your teams and have all of them add libraries to their applications that start to solve service mesh type problems, well, you could, but now you've got a big coordination challenge. And one of the brilliant aspects of service mesh is that you can solve these security, reliability, observability problems without talking to all of your engineering teams. You could do it sort of in an overlay fashion. And I think that's very powerful. Now, there are some caveats.
It's really a tool for a network administration or a deployment team. Often we see that a lot of our customers have a platform team. And so this is sort of the tool for them where they can change how things communicate with each other without having to change the communication themselves and jump into the dev teams that exist within their orgs, because they usually got some sort of organizational wall between them, and this, it really enables the platform and sort of sysadmin teams to do more.
That's right, it definitely does. So what really is the mesh? Well, really, it's just paired proxies, right? We've got a service talking to a local proxy, which then speaks across the network to another local proxy that speaks to its local service. These white arrows on the left and right are local calls, and we are presuming that they are fast and reliable. And I think that's a fair assumption, right? Local communications are pretty darn fast and reliable. The network call, though, in between, not so fast and not so reliable, and that's part of the problems that service mesh helps solve. Now, of course, you've got more than one service, more than two services. So what you end up with is something that looks more like this, where all of your services have adjacent local proxies that are proxying the traffic between the services. Now, we got to here or here without making any changes to the services and deploying proxies adjacent to them that sort of intercept the traffic between them and allow us to do things like secure that traffic, observe the traffic, make the traffic more reliable. Typically, service meshes have a control plane and a data plane. These terms just mean that there's some parts of it that route requests between services, and there's other parts of it that configure the routing of those requests. The control plane configures the data plane and collects metrics from the data plane. The data plane routes the request. Now in Kong mesh, unlike some other meshes, the control plane and data plane instances are all the same binaries. It's just Kong, 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 Kong. There is no separate binary, no separate application that you use for control or data plane, but you do configure things a little differently depending.
Yeah, so the main thing in a control plane for Kong is when you disable the proxy ports. And the main thing for data plane in Kong is just disable the admin ports. You can have both running, but obviously in a sort of sidecar environment, you don't want to be exposing your admin API to all the services in your infrastructure. So you turn that off, and your control plane is not going to be routing any traffic, so just turn proxy off. So it's more of a convention than something that you have to do, and it's optional. The other interesting side of it is that the control plane sort of gets started up first. So you need a control plane established and all your database migrations run before any data plane nodes really start up, because otherwise they don't have any configuration.
That's right.
And how are you going to talk to data plane nodes when they don't have an admin port? So you usually start up the control plane first, and that talks about plane. And for our enterprise customers, the control plane is also where, say, the admin GUI lives, and
That's right.
you know, where the dev portal products are, etc. So they're sort of so different tasks. I hope that makes sense to everyone. I would love anyone to actually provide feedback and jump in, reply in chat, or unmute yourself and have a chat with us.
Sure. One thing to call out, I mentioned this earlier, but like these little boxes, right? It's never like this. It's really like this. There's big services, small services. There's lots of traffic between some and few between others. But for the purposes of talking about service mesh and what we're doing here, it's fine for us to represent it like this. It doesn't matter how big those yellow boxes are. So James, I could talk a little bit about some of the new features of Kong that enable us to run it in a mesh, and then you could show some off. Would that be good?
Oh, we can. I was going to wait for feedback from anyone that does
Sure.
everyone feel like they understand where we're sort of coming from with mesh and what we see as the problem statement? Anyone jump in at any time?
This is Mars. It all makes a lot of sense to me. I'm really interested to see the demo because that's what I haven't seen yet.
Got it.
Sure.
Good point, Mars. Well, should we jump into the demo?
Sure, I can jump to a demo. I'll
Let's
just
do it.
share my screen.
Okay.
It's running on my laptop. You have to stop sharing yours.
Yep. Are you going to, okay, yeah. Pause that. Okay, I've paused it. Does that allow you to start it?
You've got to hit
I have
stop.
to stop it. Stop it. Nice. Ooh, James, you're in soft focus. I like that. It's romantic. Is there like a haze on your camera? Or is that
It's probably just it's probably got a smudge on
It's a
it.
nice effect.
Glamour shots.
Well,
Cool.
hold on.
Okay.
This is what we're seeing of your screen. There we go. Now it's
You can see my screen? Great. Cool. So I was trying to figure out what exactly to show you. So I've sort of just got what I'm doing here on the left. I would guess that my text is too small for people to read. Is that a correct assumption?
I can read it.
Is everyone all right? Okay.
Yeah, Mars looks
Cool.
good.
All right. So up here on the top left, I'm running just a really simple HTTP server. It just echoes it just says hello world. And it prints off sort of debug data about the request that it receives. So we can make it's listening on localhost port 8443 at the moment. So we're just going to make a request to it, and it's not going through Kong or anything. So it says hello world, and it prints off information about the request that came in. We can send data, it tells us what it saw. We could also, if we wanted to, make it an HTTPS request instead. And of course, we need to pass in -k, so it ignores certificate errors for now. And it's listening for both HTTP and HTTPS on the same port. So it'll print off like the cert that it's using and ALPN or any other thing that it receives about the request.
James, can I ask a couple setup questions here? So we're going to be trying out a mesh, a paired proxy, right? We have a service talking to a Kong, talking to a Kong, talking to another service.
Yes. So
but for this demo, unlike most sort of real world, this is all running on a single host, isn't it?
Correct. So this is all just running here local on my laptop. In reality, this is our imaginary service at the top here. This would be running on in one container, and this, you might call it a service. In this case, just a HTTP client using curl, but really this could be another service that could either be initiating requests for whatever reason, or it could be receiving requests itself and sending them off to the next location.
Right. But in this demo, we're not going to the complexity yet, but we'd like to do it for a future demo of having these services be on separate hosts.
Correct. In fact, it even gets more complex when it's on a single host, because trying to intercept your own traffic is difficult when you try and do it twice in the one place. So, we'll get to that. So I'm just sort of showing off at the moment that this is a service. So this is an HTTP service. What we haven't really said well so far is that Kong can operate both on TCP traffic and HTTP traffic. It will deal with both.
This is new. This is brand new. So up until, I don't know, a few days ago.
Until RC3, which came out last week.
Kong operated on HTTP traffic only. And if you tried to send it non-HTTP TCP traffic, well, I think it would just say no.
It would try and imagine that it's HTTP even when it's not.
When it's not. So now we support TCP traffic as well. Now this is going to be interesting and amazing, and I think we're going to see all sorts of exciting.
We're going to do a little bit more about that in other calls and other blog posts, etc.
That's right.
But
it's one of the major new features that enables us to do Kong mesh.
Yeah. So in this case, I can either, I was trying to figure out if I should demo the TCP mesh or HTTP mesh, because they operate very similarly, but with HTTP you get a few more features, and as well as connection reuse and other things that really help a lot of users. So I've demoed TCP mesh before. You guys probably haven't seen it, but I thought I'd do HTTP mesh for a change. So in this case here, we've got our service up and running. We're seeing it just tells us information about the request that comes in. Now, what I've done here is I've got two Kongs started up. I've got one in a folder I'm just calling server root A, and one in a folder I'm calling server root B. And they've been started up with these commands here. So we're using Kong prefix to tell them the folder to run out of. We're using proxy listen. So here we can see that it's listening on port 8000. We've got this new listener directive called transparent. Now this is something very special for interoperation with IP tables. We'll come back to that later, I think. And additionally, we're listening on a second proxy listen port, this time with SSL on 8443. In addition, so those are the HTTP proxy listen ports. We're now also listening on the stream listen ports, which is just plain TCP traffic, on port 8100. Now, service B here is a host. I've just modified my etc hosts file locally. And so you can see I've just named 127, 75, 78, 71 as service A, and 72 as service B. And this is just so I don't have to keep tapping out that IP every now and again. And also to make it more present that it's two different services, where these could be the IPs of two different hosts or two different containers or whatever else you might be deploying things as.
So to keep going with the list of new features that make this work, we've now seen transparent, and we've seen stream listen, the TCP listener port.
Yes, so transparent is a new listener directive. It's a very IP tables related. And stream listen is the new functionality for proxying plain TCP instead of HTTP. We've got the admin listener port on 7001 here, purely because the default is 8001, and if I tried to do it on both, they would clash and fail to start. And we've got a brand new directive here called Kong origins. So this is sort of an override to say that if Kong would connect to the thing on the left of the equal sign, then instead connect to the thing on the right. So this says that if you're trying to connect to service B on port 8443 for HTTPS, instead connect to localhost port 8443. Similarly, we've got a second item here, which says that if you are going to connect on if you are going to connect with SSL or TLS to service B on port 8000, instead go to 127.0.0.1, port 8222. And then we're using Kong restart instead of Kong start because I like to run this over and over again in case I do something odd or different or want to play with things crashing, etc.
Now, just to quickly summarize origins and transparent, these are important for the principle we mentioned in our service mesh definition, which is that we don't require changes to the applications. We need to be able to intercept incoming and outgoing requests and responses from the applications without changing the applications, right? We don't want the applications communicating outside of the mesh, because then, of course, we can't secure those communications and we can't make them reliable. But we also don't want to force our engineering teams to change their applications to speak only with the local proxies instead of just doing what they normally do. And to accomplish that, we need this combination of transparent and origins.
So being in Kong prefix server root B, we're imagining that this is the Kong running as a sidecar in front of service B, which in our case is this demo server up here. So we're imagining that's co-located, and that's why the Kong origins contains its own IP mapped to something local to it. So this is saying that the Kong running on, service B, when it receives a request for service B, really that is meant to go to localhost.
And we have to do that because if we didn't have that, that Kong that received a request for service B, the one that's running adjacent to service B as a sidecar to service B, instead of sending it to service B on the local interface, would reach out over the network and say, hey, service B, are you out there on the network?
Yeah, so it would either connect to another instance of the service B microservice, or which could just end up looping back to itself.
Which is
because
just silly,
it
right?
is service B and it's trying to contact service B. This is what allows you to break that loop.
Now notice that these configurations are not configurations that we're sending to the Kong admin API. These are configurations on the Kong instance, the specific Kong proxy instance that's adjacent to service B. And we'll have some different configurations on the Kong proxy instance that's local to service A.
Yes, so down here we've got what I use to start Kong A. So we're running in server A. We're listening on the service A host instead. We're doing the same ports as before. The admin listen is just left at the default of port 8001. And yeah, we're using the transparent option. And I've decided to exclude Kong origins here because our service A is not actually listening for anything. Our service A in this example is just curl running. It's not listening for requests. So it's purely originating requests. So
That's right.
I haven't bothered to put a...
We've simplified this example, right? Service A doesn't listen. It doesn't accept incoming requests. It only does its own thing. Hey, maybe it's like a cron job, right? It triggers and does its own thing, but it doesn't do anything in response to incoming requests. We know that's not terribly realistic, but it definitely simplifies this example here.
Yeah, you can go very overboard with scenarios trying to show this off. So it's difficult to condense it down to something realistic and understandable.
If those configurations aren't stored like globally, where do they live?
So this here is purely we're passing them environment variables. You can also put them in Kong.conf, but usually this would be things that you pass to your container orchestrator. So either Kubernetes or if you're using Mesosphere or any of the other sort of orchestrators or container runtimes, these will be things that you pass in. Obviously, if they're data plane nodes, they don't need an admin listen. We could just change this to admin listen off. In the case of a data plane node, and this I've sort of gone for the odder case of they're both running at data plane nodes. We don't have the control plane data plane separation.
Sure, in this case, right. Now we've got a question from the audience. So where does the database which Kong uses reside? Great question. It resides wherever it used to reside. There's no change. So when we talk about moving to Kong Mesh, some things, we get some new features, but other things stay the same. And the database part of Kong Mesh definitely stays the same.
Just to clarify that the Kong remains in its current state, which you probably know today. It still needs database access. The data plane nodes still need to contact the database. So in fact, the control plane and data plane don't communicate directly. They communicate via the database. So you talk to the control plane, you send your configuration, and it then writes that to the database. And then the data plane nodes pick that up from the database.
That's right. They pick it up when they need it. And then because of our well-engineered caching, they tend to keep it for as long as necessary. Until it changes or until they need to get fresh information. So the Kong node to database communication, there may be some at startup or sort of when Kong node is encountering new requests that it doesn't know how to deal with. But as each node fills up its local cache with sort of known configuration from the data store, that communication between the Kong nodes and the data store will decrease, typically.
Tailing question to that, is the control plane actually another instance of Kong that basically...
Yes.
Okay, so it basically is like a Kong that isn't really acting like a proxy. It's really an admin API to send and receive config from the database.
Exactly, and we could easily start up a control plane Kong in this demo by, let's call it server control plane.
Live coding.
Yes.
We turn off proxy listen. Stream listen is off by default. Admin listen, we can put it on some other number, short 6001. We don't need the origins directive. And I should just, for the sake of it, put dash control plane on this tail line. So first let's restart this tail. And I've actually just quit it. Well done. So we're just going to continue tailing that. And we can start up what we are now calling a control plane node. So, oops, need to...
While James is doing this, I'll just speak to Sean's question there that you wrote in the chat. So would a typical use case be that a given app and all of its services have its own dedicated control and data plane Kong environment? So yeah, a given app and all its services, we're mostly talking here about a collection of microservices or a collection of applications. They could be micro or macro or very small indeed functions within a given computing environment that you have control over, right? So if you can control the way that the Kong nodes are deployed and the way that the hosts are configured within the computing environment, then yeah, you would ideally put a local Kong proxy adjacent to every application, service, instance. They'd all connect to a data store to get their config, and then you would also have a control plane Kong, or even more than one potentially, that you as an administrator would connect to make admin API calls, to retrieve metrics, to do the sort of typical control functions.
So the big thing is that a Kong cluster, which is really a collection of control plane and data plane nodes, or a mix of the thing, is really a boundary of trust. It's when you trust that essentially your administrators, people that have access to that, are all people within your org, and that really it's within a single org. So a lot of organizations will just have one Kong cluster, and they'll have the production Kong cluster. It'll be just one of them with one control plane and a data plane node for every service they're running. Other orgs might have, one for production, one for testing, one for staging. Other orgs might have, maybe per department. So they'll have each department has their own Kong cluster because they want to upgrade, say, Kong individually. They have their own organizational sort of structure where they want to independently control their clusters. But generally, there's very few Kong clusters within an org.
We tend to recommend fewer. Fewer tends to be better than more Kong clusters, if you have a choice.
So it's really the largest trust zone that you can really come up with within your org.
Here at Heroku, we call that blast radius. And the idea is that while you can have a huge thing that covers everything, that means that huge thing can take down everything. So you might want to think about it in terms of what your smallest reasonable blast radius is, so that, you know, problems don't reflect in like your whole mesh going down. Like, I don't know what, since it's one centralized Postgres database, at least in our instance, it's a challenging question, like how big you really would want to make that.
We sort of dealt with that as the failure scenario very differently. So the data plane nodes won't stop processing traffic if Postgres is unreachable. You know, they just will, you won't be able to write to Kong, you won't be able to change configuration. However, the existing nodes will continue running as long as they want. It doesn't actually result in an outage. So it's really about what is your organizational trust, rather than dealing with sort of failure scenarios of software and networks at this point.
I would definitely be curious if you folks have any like freely available like papers or documentation about the kind of failure modes that you've been testing and how you can prove this. Otherwise, it's like, you know, I would have to figure out how to prove what you're claiming.
Yeah.
So I mean, the biggest thing really is that Kong only, it polls the database for new configuration. If the database is unavailable, then it can't get new configuration, but it doesn't change any behavior.
The key thing that James said there was new configuration, and this is what makes sort of speaking generally about this a little tricky. Different Kong use cases have vastly different sort of volumes and frequencies of new configuration. In some Kong use cases, configuration is changing many times a second. In other situations, it maybe only changes once a year. And so because of that, it can make it tricky to sort of make one blanket statement about how reliable the data store and Kong's connection to the data store needs to be.
And that also is a reason that we do support Cassandra as an alternative to Postgres. For people that really need to deal with sort of multi-region or, you know, really deal with changing configuration while they have network outages, we do support Cassandra as a database in addition to Postgres.
That would be really cool documentation. That's super awesome.
Sure.
I would love to, like, what happens when everything explodes documentation.
And that goes for Kong in general. That's not specific to service mesh. That is, you know, if you're running Kong as an edge gateway for your whole infrastructure, you know, we've been dealing with those sort of outages and problems for years. It's exactly the same sort of scenarios.
And mentioning blast radius, Mars, one of the ways that Mesh helps reduce the blast radius is by now enabling you to run local Kong proxies. So you have a proxy adjacent to every service instance. In the previous iteration of Kong, running pairs of proxies was not really possible, which meant that service-to-service communications had to go through a Kong cluster, which might have had a slightly larger blast radius. So even the move to Mesh is about reducing blast radius. All right, we should keep going with this demo, huh?
Yeah, there's one more comment, which is that Sean says, I think Mars makes a good point, and perhaps there's a middle ground where organizationally or administratively you have a single local Kong environment, but at the implementation level, you leverage distributed deployments to limit blast radius.
Possibly. I mean, really, I do agree with James. The blast radius is really decided by the data store. Like, that's the data store and the frequency with which your Kong nodes are needing to connect to it. And if they're, you know, if they need to connect a lot, then your data store defines the blast radius. If they don't, and they can quickly sort of retrieve and cache their config, and then their config doesn't change, the blast radius is defined, I don't know, by the extent of sort of the traffic that each individual Kong node is proxying. because once they cache config, they just run.
Cool.
All right.
So we've just made this quick change to our demo here. We've started up a third Kong. Let's just change this to 3 Kongs.
You are brave, James.
And so we've now got this data control plane node running. We can see that we connect to it on port 6001. It's not running a proxy port or anything, but we could be sending our configuration there. So yeah, we could turn this off or whatever we want to do, really. You can configure Kong however you want. Cool. So then I've gone in and added a service with the name service B, where it points to the URL HTTPS service B port 8443. And then I've added a route to that service, which says that match on service B. That is just the same as the Kong admin API today, if anyone is familiar with it.
And notice in this demo, those are the only 2 configurations that we did by calling the admin API. Everything above those were done by configuring environment variables or Kong.conf.
Correct. So this Kong, this is your control plane Kong, which would be running constantly wherever you need it to be, off to the side with your infrastructure. This Kong is the one that you would deploy at the same time as Kong B, right next to it as a sidecar. And this is the Kong that you would deploy with service A right next to it in a sidecar. So notice that the config in the one for B, it doesn't say anything about A, it's all just service B specific config. Likewise, the config for Kong A only has service A related config. So it's really just about making sure that you know what each Kong is in front of and what each Kong is responsible for. And then, yeah.
When you declare the first add route and you set the URL to service B is the host, what defines what service B is?
Oh, that's just because I cheated and put it in my host file before.
Gotcha.
Normally that would be an actual, DNS in your infrastructure or something. For the sake of demoing locally, I chucked it in the hosts file.
Now, James, am I understanding correctly that service B doesn't actually speak TLS?
Correct.
Right?
So
okay, we'll come back to that maybe, or you can
yeah.
talk about it now.
This is sort of an older, a greenfield deployment, you might say, where I'm just saying that service B speaks HTTPS, when in reality, well, actually, it speaks both, really.
Let's pretend it doesn't.
Right. So what this does is that saying that if there's a request destined for service B, then connect to service B, which is a little confusing. But now if we jump back over here and look at the Kong origins option that is running on Kong B, we can see that if there is a request destined for HTTPS service B 8443, instead direct it to localhost non-HTTPS port 8443, which is this server running locally here. So,
and the reason that is helpful is because now we're in a position to cause communications coming across the network to service B to be run over TLS without changing service B to support TLS. And as we had in our service mesh definition, we want to solve problems related to, in this case, security without requiring changes to the applications.
Yep. So in here, we're going to do a curl request. It's a curl request to service B, port 8443. But notice that it is going, this is -X is the proxy option to curl, which says that send this via the proxy service A port 8000. And we can see that proxy listen service A 8000, that is where our Kong A is listening. So we should do this request. It should go through Kong A, through to Kong B, and then through to our service at the end. So in our tailing of the logs here, we should see logs from both Kong A and Kong B. And if I cross my fingers, this will work. Great. So we see it went through Kong Kong A and Kong B, and in Kong A we saw that we've got a request destined for service B, and in Kong B we saw that we've just got a get which went through. We can see that we got a hello world and the request came through with not HTTPS. So that's sort of all of it together. That is sort of the demo of the HTTP mesh in the simplest way I could think of.
Questions?
I keep lobbing them. I'm sorry if I'm overpowering.
Send them.
Everyone else, you're welcome to ask questions.
So the inter-service or in-mesh HTTPS, like this one where it's HTTPS service B and service B isn't really running HTTPS, is that just magical with the new mutual TLS built-in certificate authority stuff?
Yes, it is.
Awesome.
We didn't touch on that part.
So we've got our sort of communication. I'll just try and write at the bottom of here. I hope you can read this. So we've got A going to Kong A, going to Kong B, going to B. So I've used one of Cooper's notations here, which is the big fat arrows, which are TLS,
Sort of like that, yeah,
and skinny arrows are
Local.
just unencrypted communication.
Oh, sure. Okay.
So when Kong A reaches out to Kong B, we advertise as part of the TLS handshake, hey, are you part of the same service mesh as me? And if Kong B replies, yes, then we do Kong mutual TLS. Otherwise, anything that doesn't know what Kong mutual TLS is or isn't part of the correct service mesh, we'll just ignore it. And this goes for any TLS service out there in the world. It will just ignore it. So that gives this sort of gradual and configurationless TLS communication between Kong nodes.
This is a new feature, and we'll be detailing it in blog posts and documentation as well. It certainly requires that all of your Kong nodes are up to date.
So this is nearly all the things mentioned here. The new mutual TLS stuff, the stream listen, transparent origins is all part of RC3, which came out last week.
Or RC 3.5, maybe RC 4. So
it's all in RC3.
There's a further element that we haven't shown off here. We'll be talking more about the future, which is how plugins run. Plugins still exist in Kong Mesh, and they're part of the great value you get from Kong is that these proxy nodes can be extended, enhanced, improved with plugins. But when we have Kong talking to Kong, we need to have some control and awareness over where the plugins run. You can imagine, James, can you put your diagram back?
I just deleted it.
There we go.
Undo.
You can imagine that if KA and KB both ran, say, a rate limiting plugin and incremented a rate limiting counter, we'd get 2 increments for a single request. And that's certainly not what we want. So Kong has one more new feature, which we'll show off in a future call called Run On. And it controls where the plugins run on. Do they run on KA? Do they run on KB? Or do they run on both? The Run On feature is totally dependent on Kong certificated mutual TLS being established between the 2 Kong nodes so that the nodes can be aware of each other and thus decide or correctly determine where to run the plugins. We'll cover that detail in a future call.
Cool. Yeah, I think we're running out of time for me to demo that right now.
Yeah. More questions?
Anyone else?
Mars, you can go again if you want.
All right.
So call to action. We'd love for you to try this out. I will admit that there is an issue with the current RC3 release that will cause the TLS aspects of it to probably not work correctly. So you may want to wait for 1.0.0 RC4, or who knows, maybe there's a 1.0.0 RC 3.5? I don't know.
Yeah, there's, if you wanted to try this today, you do have to build from source. Our Docker images that got built for RC3 are missing a flag. So they, if you want to try this, you will need to build from source. I think we're trying to rebuild the Docker images today or tomorrow because we only tried this when we tried to come up with a demo and realized that Docker images are broken. So that's why we have RCs.
Sure. Another thing I'd like to throw out there for the community is community call is what you see here in this demo is you could just count the number of lines, way more local config of individual Kong proxy nodes and not very much admin API config. This is what is necessary for Kong Mesh to work. We're interested in exploring and understanding how this local config will be streamlined, automated, made sort of more straightforward and understandable.
So yeah, what I definitely should mention is that all of this local config, this is if you're going the very manual route. If you want to use Kong Mesh when your own homegrown designed deployment scenario, these are sort of very raw, low-level options that Kong needs. If you're operating in environments such as Kubernetes, then you can automate nearly all these config options because you know where things are deploying. So we're actually going to be distributing this, no, not this one. Do I have it on here?
Are you working on it? There it is, Kubernetes Origin Manager.
Where?
I saw it at the top. I don't know, that tab we were just looking at. So we're thinking about and working on some sort of automation and enhancement here.
Yes.
And we'd like you to keep this in mind as well, right? We don't expect everyone to be doing all of this local proxy config manually like we're doing it every time, but understanding how and how it works, we think is an important part of sort of fully understanding Kong Mesh.
Yes, so what we're including, or we're going to be including very soon in Kong, is what we call, or what is called a Kubernetes mutating webhook admission controller, which is a bit of a mouthful. And what it does is it monitors in Kubernetes of every time that you want to start a service. And when you do start that pod, along with the service, it injects a Kong sidecar into that for you. And so this manages all of these, this is like an early draft, manages all these settings for you so that you don't have to put all these in yourself in the Kubernetes world. It's done all for you. Obviously, if you're not using Kubernetes, you'll need to write something similar or do it manually, but because...
And we'd love to see what you come up with there.
Yeah,
and it does remind us of a really important point. Kong Mesh does not require Kubernetes. Kong Mesh is sort of deployment agnostic. You can form a Kong Mesh between almost anything, almost anywhere, can't you, James?
Yeah, so you could be running these, Kong A and Kong B. In here, I've done them on one computer. You could be running them in different containers on the one node. You can be running them, on different VMs. You can be running, service A can be, off on bare metal, and service B can be in Kubernetes. We sort of orchestration tool agnostic so that your service mesh can span all your infrastructure, no matter where or what tools you're using. And this was a big influence in the design of our service mesh because not everyone is using Kubernetes everywhere, but they want to, have a service mesh, which is, I think something pretty unique from Kong.
Absolutely. The benefits of service mesh are way too valuable to restrict to the Kubernetes club members. We want it to be much more accessible.
Cool. All right. So I put a link to Kong Nation in the chat. So if you have other questions that are just burning and you can't wait or aren't burning, please join Kong Nation. It's our discourse forum, and drop your questions there and we'll get them answered for you. And in our couple final minutes, I wanted to...
Do you need him to stop sharing?
No, I think
I can stop sharing my screen.
I wanted to give a quick plug for KubeCon.
Hey.
So we will be at KubeCon next week. We're super stoked about it. We're going to have an awesome booth right over here in the hall at booth S33. So you'll come in the main entrance, you'll walk by the Oracle Lounge, you'll go down the hall and you'll find our little booth. And you can come by, win a Sonos in our raffle, spin a big wheel for a t-shirt, and talk to our engineers. We're gonna have Harry, Josh, and Cooper. And hopefully Thibaut and Marco will hang out at the booth a little bit as well. So we will see you guys there if you're going, and please stop by and say hi. We'd love to talk to you. So with that, we'll give you all 1 minute back. Thanks guys so much for joining us. We will talk to you next time. I think the next call is scheduled for January 15th. So if I don't see you before then, have a good New Year. Great. Thank you.
Thanks, everyone.
Thanks. Happy New Year.
Thank you, Mars.
Thanks.
Bye, everybody.
See ya.